This is my presentation for the solution for MHFOE Unit 3 mid-unit assignment. So, for the number question 1, describe what happened to the domain and range of logarithmic functions under a vertical reflection. Support your explanation with diagrams. So from the question, we need to know that vertical reflection is the same as the reflection and x-axis. So before we start off, we need to let parent function be something. So I let my parent function y equal to f of x equal to log x. So I've already drawn the table for the values of f of x equal to log x. So for the any values for the x and the log x, it cannot be 0 or less than 0 because it's undefined. For example, log 0, it's undefined. And so, for example, and as for another example, log -1 or -2 or -3, it's undefined. So it has to be, so the values of x has to be greater than 0 and not 0 as well. So this is my table for the values. And so for the domain, for the f of x, like I said before, x has to be greater than 0, not 0 as well. And then also it belongs to a real number. So for the range, f of x belongs to a real number. It can be anything, since the values of x is greater than 0. So let's go back to the questions. Vertical reflection, like I said before, it's a reflection in x-axis. So the transform function is going to be I let g of x equal to negative log x, because we get that according to the function a of kx minus t plus c, the values for a is -1 when it comes to reflection in x-axis. So this is a reflection in x-axis, so the values of a, which is right here, is a -1. So -1 times log x is negative log x. So this is going to be the transform functions. So I have already drawn the table for the transform function, and also domain of the transform function. Since it is a log x, or not like something restricting the values of x, for example log 3x, 2x, so it's just a log x, so it's the values of x is always going to be greater than 0, and the values of x belongs to r. For the range as well, they're the same. It's just reflection, so they're the same. The range, it's gonna be the same. It belongs to real numbers. So for the graph, the blue one, is my graph for the parent function y f of x equal to log x. So from in the table, even though I only added the value for x equal to 1 and y equal to 0, I continuously drew the line, like as not as a asymptote though, but I continuously draw the line because I want to show that there is a lot more value between 0 and 1. I mean greater than 0 and less than 1. So because I only studied the values of x as 1, so log 1 is 0, log 1 is 0, so my graph is always going to be like this, but intentionally drew this because I want to show that there's a lot more value. And also the same as the transform function. So this is the red line from right here to right here is my graph according to the table, but I also intentionally drew the graph because I want to show that there's a lot more value as well for the function, negative log x. So this is my answer for number 1. This is simple. So for the number 2, describe what happened to the domain and range of the logarithmic functions under both a horizontal and vertical translation. Support your explanation with diagram. So let's say, so we have to underline horizontal and vertical translation. So that's the main point. So from the question, we need to know that a vertical and a horizontal translation, they're talking about the values of D and C. From the equations a f k x minus t plus c. Since the values of a and k, they're talking about either the graph's going to be stretched or compressed, so we don't need to think about that. So this is about translation, so we need to think about the values of D and C. So it's the same as before. We have to let parent function be something. So I let y equal to f of x equal to log 3x as my parent function. So I've already drawn the table for the value. So for the domain, there the values of x is gonna be greater than 0, because if you put 0 right in the function, log 3 times 0 means log 0, which is undefined. And if you put the negative value as well, for example, a negative 2, log 3 into negative 2, which is a log negative x, which is undefined as well. So according to the rule that the values of x in the function log x can be 0 or negative values, only accept the positive value. And also, yeah, this is the domain. And so for the range, it can be any number according to the x. So it belongs to a real number. So for the transform function, first thing, a vertical translation, which is the values of D. So I added the values of D equal to 0. And also the vertical translation is 2. So my transform function is going to be log 3 times x minus 3 plus 2. So I've already drawn the table for the values of my transform function. So the domain is gonna be greater than 1, because if you were to put 0, 3 times 0 is 0, 0 minus 3 is negative 3. Log negative 3, it's undefined. So for example, negative 2, 3 times negative 2 is negative 7, negative 6 minus 3 is negative 9. So log negative 9 is undefined. So the only values you can substitute as x is all possible positive number, but greater than 1. And yeah, x belongs to real numbers. For the range, so and whatever the value you get from this part, log 3x, you have to add you have to add 2 to the value you got. So for example, let's say you got 0 from this first part, you have to add 2 to that. So 0 plus 2 is 2. So if you get, for example, 3 from this log 3x minus 3, you have to add 2 to that as well. So 3 plus 2 is 5. So the value is always going to be 2 or greater than 2, not as the less than 2 though. So for the range, so g of x, it's going to be greater than or equal to 2, and it belongs to a real number. So I've already drawn the function on the graph. For the parent function, so this is a log x, so this is the graph for the f of x equal to log x. And then for my transform function, since I've already drawn the table for the values, so this is my transform function. So if you were to check whether if that's correct, this is my parent function and this is my transform function as well. So for the values of D and C, I've added 3 and 2, which means the horizontal translation to the right is going to be 3 units, and the vertical translation upwards is going to be 2 unit. So, but in this situation, there is 3 restricting the values of x. So it's going to be, if you were to simplify this, it's going to be log 3 bracket open bracket x minus 1 close bracket plus 2. So this there it's going to be the same. Yeah. So for my graph, it's only going to be shifted 1 unit to the right, because this is same as log, like I said before, this is same as log 3 open bracket x minus 1. So the values of d is going to be only 1 in this situation. So it's going to be shifted 1 unit. And also for the values of 2, it is a vertical translation upward 2 units. So if that's, it's going to be checked. So 0.5 plus 2 is 2.5, and then it is correct. So this is my answer for number 2. So for the number 3, graph the function f of x equal to 1 over 2 log x minus 4. So I've already drawn the table for the value for this function. So since it is just log x, so the values of x is always going to be 1 or any positive number, but not 0 or any negative number, because they're going to be undefined. So this is my value for that. So this is my graph for the function. I've intentionally drawn this asymptote because it's going to be later on the questions. So yeah, and also graph the line y equal to x on the same grid. So this is my table for the values, and this is my line. So it's easy because it's just a simple function. So y equal to x, this is going to be like this. Yeah. So for number B, graph the inverse function f of inverse of x by reflecting f of x in the line y equal to x. So there's no need of drawing a table or any other things that we normally do, but it's just gonna be it's just, I imagine this is a paper. And this is folded diagonally like this, and then if you were to fold it like along this y equal to x line, so this line, this function from the f of x, it's gonna be here. It's like a paper folded diagonally, and you have to fold it to see what image is gonna be on the other side of the folding line. So it's gonna be like this. So this is as easy as we do. Oh yeah. Also, for the number C, determine the domain, range, and equation of the asymptote of f of inverse x. So for the domain, it's the same as the f of x greater than 0, because any values of 0 or less than 0, it's going to be undefined. So x belongs to real number. But for the range as well, y going to be greater than 0, and y belongs to real number. So also the equations of the asymptote, it's y equal to 0, which is along the x-axis. So for number D, determine the equations of the f of x. So as usual, we have to let f of inverse x be something. So I let f of inverse x equal to a. So according to the rule that the domain of the f of x is equal to the range of the f of inverse x. And again, the range of the f of x is equal to the domain of the f of inverse x. So which means in this situation, this function is going to be like this. So this is the inverse. This x is the domain of the f of inverse x. F of inverse, the domain of the f of inverse x is equal to the range of the f of x. So this is going to be the range of the f of x. I mean, in this situation, it's f of a. So yeah, f of a equal to x. So we have to substitute a to the x. So 1 over 2 log a minus 4 equal to x. We have to add 4 to the both sides. 1 over 2 log a equal to x plus 4. So log a is technically log base 10a. So this is going to be base 10, and we have to multiply 2 to the both sides. So it's going to be just log base 10a equal to 2x plus 8. So we have to change it from the logarithmic function to this function. So a equal to 10 to the power 2x plus 8. So since we have already considered that f of x is equal to a, so the value for f of x is the same as the value for the a. So this is going to be f of x equal to 10 to the power 2x plus 8. So this is going to be the end of the presentation of my solution to the mid-unit assignment. Thank you.